In our final example, example 7, researchers recorded that a certain bacteria population declined from 452,786 to 418,210 in 12 hours after the administration of medication. We want to use Symbolab to complete the following. In part A, find the rate of decay for the bacteria population. Here we'll still be using that same formula, A equals P e to the RT. We know the final the final population, which was after 12 hours, 418,210. We know the initial population was 452,786 times e to the r, which is our unknown value in this case, times t, which will be 12 hours. We'll plug that information into Symbolab like we've done with the other examples and solve, which will give us a value for r of approximately negative 0.0066 or negative 0.66%. That's our value for r, but again, when we report the rate of decay for this population, we would say the rate of decay is 0.66%. Since that statement decay already implies that this is a negative value. And then in part B, we're asked at this rate of decay, so assuming that percentage holds, how many bacteria will there be in 48 hours? In this case, it's the final amount that's the unknown. We know that after 12 hours, we are at a population of 418,210. E to the negative 0.0066. And then we're wondering about in 48 more hours, so we'll plug in t equals 48 hours. And evaluating this expression with Symbolab would give us an answer of A equals 304,656. Rounded to the nearest whole number, since we're talking about population of bacteria, we don't have half of a bacteria. So in each of these cases, we need to make sure we're keeping in mind when we report rate of decay, we do that as a positive value, since the language implies that's a negative result. But when we substitute that value back into the exponential equation, we need to make sure we plug it in as that negative value so that we're getting decay instead of growth.